Great. Hi, Bob. So for those of you that don't know, Bob Sorensen is a Senior VP of Research and Chief Analyst for Quantum Computing at Hyperion Research. Specifically, he helps drive research and Hyperion's consulting efforts in the US, Europe, and Asian Pacific markets on topics covering technical servers, supercomputers, clouds, high-performance data analysis, and quantum computing. Bob advises a diverse and international client base on the global HPC sector status and prospects through strategic research projects, single and multinational government studies, international competitive research analysis, and technical trends. His areas of expertise include analysis of HPC hardware architectures and interconnects, benchmarking performance analysis, and assessments of emerging and disruptive technology, of which quantum is certainly an important part. So with that, I'm going to turn it over to Bob. And again, if you have questions, put them in the Q&A box, and we will take some at the end.
Great, thank you, Susan. I appreciate the gracious introduction. So we'll just jump right into this. This is going to be basically an overview of research project that we recently completed for D-Wave that was really trying to understand exactly what was going on in terms of broad interest in quantum computing as the driver of commercial success. And we'll get into a lot of the details of that before we go forward. But the first thing I do want to mention, because I think it's important from a perspective of objectivity, is that D-Wave was very gracious in terms of allowing us to do the study and making literally zero editorial or other marketing types of decisions or directives in terms of where they wanted this project to go. In fact, I can tell you that the deck you're about to see, no one at D-Wave has actually reviewed it and know exactly what I'm going to say right now. So at a minimum, Susan will most likely be on the edge of her seat as we go forward, as we see how I've summarized this particular activity. Well, one of the things I'd like to do first, if I can get the slide to advance, there we go, is just give you a quick background. And this is not a paid political announcement for Hyperion Research. It's to really just tell you a little bit about our pedigree, to give you some perspective on how we come to quantum computing. Essentially, Hyperion comes out of the HPC world. And if you go back long enough, you talk about the kinds of systems that Seymour Cray used to make, CDC, places like IBM. And if you want to go way back, organizations like Thinking Machines or Kendall Square Research, MassPAR. So the bottom line is we have always looked at advanced computing wherever it may be. What's the next bright, shiny object in terms of serving interesting science and engineering workloads from an advanced computing perspective? And so really about 5 or 6 years ago, we started to get a lot of questions, not only from our HPC user client base, but our HPC supplier base, saying, okay, what exactly is going on with quantum? Is this for real? How can we start to think about bringing quantum into our ultimate computational arsenal, whether it be from a supply or a user perspective? And so we come to this problem not as looking at quantum computing as an island that happens to exist distinctly from the classical IT world, but we look at quantum more as yet another aspect of advanced computing writ large. It's another tool in the toolbox to be used to solve some of the most interesting and compelling performance-restricted workloads that are facing scientists and engineers around the world. So that's just to give you a quick perspective. So let's jump into where the study goes. The objectives of this particular study, as we see here, is to glean end user perspectives on commercial prospects. If you look in the popular press and some of the technical journals, there's an awful lot of going on in terms of quantum computing technology development. It's companies like D-Wave, like IBM, like Rigetti, like IonQ, and a myriad other software vendors and hardware vendors I didn't mention are out there doing lots and lots of push, if you will, in terms of developing the technology. And really what we wanted to do is get a better sense of what's going on from the user perspective, because ultimately these are products that are being built to solve end user problems. And so the goal of this really was to try to extract the key insights from the commercial quantum computing end user. What is their awareness on quantum computing? What are some of the use case and applications that they hope quantum computing can address? What are their procurement and buying decisions? And ultimately, what do they see as the challenges and opportunities of bringing a quantum computing capability into their existing classical IT infrastructure? Well, the target of the folks we wanted to do to complete this study was to go out and to do a survey of the end users that are out there right now. And what we wanted to do was we wanted to reach global decision makers who are actually involved in the company's strategic technology planning. We didn't want to go to, for a lack of a better term, the quantum evangelists that happen to sit perhaps in the R&D department of a particular organization. We wanted to talk to the technology planners, the folks that actually look at strategic planning and business process from a high enough level so they not only have the ability to make decisions, but to actually implement them and to make change within their organizations. And to do that, we wanted to really reach out to companies with at least a $50 million budget estimated for 2021 revenues and an annual IT budget, classical at this point, of at least $5 million. We're really trying to get a hold of the larger players, if you will, in the sector. I'm going to cut right away to the chase and give you some of the key takeaways that this survey that fed into the study concluded. Right now, almost 70% of the companies that we surveyed, and we'll get to the demographics in a minute, but there were over 400 that we did survey. Almost 70% of those companies surveyed already have some form of an in-house quantum computing program, and we'll get to details about that. And some of them are really in a exploration phase where they're looking at what quantum technology is out there. They're considering what's going on, but some organizations we identified already have proof of concept research programs going on, and some other very definite activities. So a lot of companies interested in it. We found that about 30% of the companies that don't have programs right now, of that, 2/3 are planning to do so in the next few years. And that leaves a vanishingly small percentage. I think I want to say about less than 11% of the organizations we talk to that have no quantum computing program right now and have no plans to do so in the next few years. So you could basically say within the next few years, about 90% of those 415 organizations we surveyed will have some activity in quantum computing. Well, that's because quantum technology is seen as offering a range of corporate level benefits. And the ones that were most cited were improved research capabilities. And of course, first and foremost on the minds of many C-suite executives is how that drives increased revenues. And the things that we found these end users are looking for, they want solutions that can deal with problems in optimization. They want to improve, say, efficiencies in factory processes, scheduling, all the sorts of things that we really see being the sine qua non of quantum computing. Every vertical we surveyed, I think we ended up talking to 19 different verticals within the commercial space, had some level of quantum computing activity going on. Some more than others, but in general, and if you download the paper and look, you'll see that no particular organization stands out as taking a leadership role in quantum computing. It definitely is an area of interest within the entire 19 verticals that we spoke to. And what we found kind of interesting here is that most of the companies that we surveyed already have classical-based activities in data analysis, machine learning and deep learning, optimization, mod sim, and material science. And what's interesting is those are right now the key technologies that offer the most promise if attacked with the quantum computing system of today and the near future. So there's already a confluence of interest from end user perspective in terms of what quantum can bring to the table. So I'm going to hopefully not bore you with the demographics, but to me, it's important that if you want to believe the opinions and findings of the studies, it's important that you have a better understanding of who did we talk to? Did we talk to the right people? And are they the ones whose opinions we could go, yeah, they're in the position to make the best about the judgment. So I'll go through the demographics quickly. But as I said, I think it's important to understand exactly who we spoke to and why their opinions actually have some deep validity to this process. So as I said, the study draws heavily on this Hyperion Red QC end user survey, 415 different responses from different respondents who consisted of decision makers, influencers, and stakeholders involved in strategic technology planning at their organization. Those respondents represented companies in the US, UK, France, Germany, Italy, Spain, Switzerland, South Korea, and Japan. So we really managed to try to cast, and we successfully cast a very wide net when it came to global perspective. As I said, there were 19 key commercial verticals surveyed. We'll talk about in a minute. And the survey fielding dates were a rather short period of time, basically mid-September, 9 days, only a few months ago. So at a minimum, the data results are relatively recent. So first demographic, where's your organization located? As you can see here, about a third of the respondents were US, but here's where we get into the UK, was about 17%. If you clump all of the EU organizations, EU member countries together, France, Germany, Italy, Spain, Switzerland, not Switzerland, you get about a third of the respondents coming from the EU. And we hit some good results having exactly 65 respondents coming from South Korea and Japan, representing, we think, a good view on what's going on in the Asia Pacific region. As I said earlier, we wanted to focus on larger companies with significant IT budgets. And this is the chart on the left here is more or less a histogram of the revenues of the companies we talked to. And as you can see, the real sweet spot here was overall 21 company estimated revenues between $501 and $1 billion. But we also talked to a number of companies that had revenues above 10 billion. And we also reached down to at least get a sense of what was going on at the bottom level of buy-in for this particular study, which was $15 to $50 million. On the chart on the right shows their overall computing budget as it now stands, and we're looking at really averages between 10 and $50 million. The ratios here between companies' overall revenues and IT budgets are the kinds of things we come to expect when we look at companies that are actually involved in significant research and development activities that require a somewhat sophisticated IT infrastructure. So these ratios are ones that we were very happy with, that we felt like we were talking to the right kinds of companies in terms of advancing R&D as part of their overall corporate agenda. And as I mentioned earlier, we did want to make sure we were reaching the key decision makers. And these are really when we asked them, what is your role within your organization? As you can see, we hit about 61% are decision makers. They make the final call on what and what not to purchase. But we also managed to cast the net on influencers or stakeholders, folks who may not be involved in making the final decision, but either they have an invested interest or they help inform those decisions on those final efforts. So again, the key here was to reach the key decision makers in a company. And just to put a little more detail on that, these are the kinds of job titles of the folks we talked to. And again, the goal here was to really hit the C-suite folks, the folks that have the first letter C in front of their job titles. So we hit CIOs, we hit CTOs, and we hit VPs of innovation or directors of innovation with almost a complete coverage there. We also hit a number of folks that had some other interesting job titles, but the key gating factor to all this was making sure that they had at least a reasonable or very strong understanding of what the quantum computing program status was within their particular organization. So those that said, I have no idea what's going on in quantum computing in my organization, they were gently moved to the side and went to find other folks. I talked about those 19 commercial sectors, and this is more or less the percentage of the verticals that the line on the right are the verticals that we went after, and the percentages on the right is the share of organizations that we got there. As you can see, we hit software and internet, computer, electronic, and optical devices make up about 50% of the organizations. And then we move down to financial servicing, computer-aided engineering, retail, and commerce, all the way down to defense and pharmaceutical organizations. Now, the key here is that if you have been doing the math at home, you'll see that this adds to more than a 100 because we didn't want to artificially limit an organization to one of our particular predefined verticals. So if a company felt that they basically were involved in software and hardware in the IT sector, they could check both boxes on that. Same with things like advanced manufacturing or computer-aided design, computer-aided engineering and such. If they felt that their main areas of activity spanned our verticals, then they were free to really capture that in more than one entry. We wanted to know a little bit more about the computing environment that we were speaking to. So we started really at the top with it, which would be kind of the traditional HPC research environment, the kinds of environments that you'd find at a very progressive scientific and engineering company, or what you would see perhaps in say a government lab. But really the emphasis there is on high performance computing research environment. We hit about 25% of that. Then we dropped down a little bit in terms of aggressiveness of technology adoption and use. We hit about 21% folks who were involved in HPC, but in a production environment. And a good example there would be, say, an oil and gas company that is consistently doing reservoir modeling, extraction, or other kinds of production environment jobs that they run on a regular basis using data that's been gathered in the field. They're not doing an awful lot of innovative R&D programming, but they're really involved in a production level HPC environment. Then we managed to hit about a third of organizations that have a mix of high performance computing and enterprise IT environments. And then basically we hit a number of organizations that consider themselves primarily an IT shop with some HPC and a very small percentage who consider themselves an IT shop with no HPC. So, but really the takeaway here is the broad range of organizations we hit. We didn't cherry pick the most aggressive technologically advanced HPC centers. We really wanted to gather a range, especially hitting organizations that are that are primarily, or at least have an existing composition of HPC and, perhaps more importantly, enterprise IT workloads. So now that we've got the demographics out of the way, let's get on to some of the HPC, or excuse me, the end user QC perspectives. So when we asked them about the current state of quantum computing in their organization, we found out, as I said earlier, that many, in fact, almost half, were exploring options in monitoring technology developments. And again, here, the numbers add up to more than 100 simply because we gave the respondents the ability to pick more than one answer on any given thing, especially if they had more than one quantum computing program that they were aware of in their organization. We didn't want to limit them to picking one that was perhaps the best funded or the most recent or the most visible. We wanted to make sure that we could capture the span of activities. But clearly here is about 48% of organizations we spoke to said that they were exploring options in monitoring technology developments. About a third of them are conducting quantum use case analysis and prioritization to figure out exactly where they should be thinking about implementing quantum computing solutions and in what order. As I said, about a third proof of concept research programs underway. About a quarter have fully funded research efforts underway. And then we also saw about 23% looking at limited in-house pilot programs going on at this particular point in time. As I said, right now, look at 20%, about 1/5 of the respondents have no current activity, but do plan to start up in the next few years. And only about 8% had no activity and no plans to do so in the next few years. So as I said earlier, that really, if you add that up, that means within the next few years, it's reasonable to conclude that about 90% of the 415 organizations we spoke to during the survey plan on having some form of a quantum computing activity in-house. Well, this is a horrible eye chart. You always have to do at least one of these and apologize for it. But what I wanted to do is give you some sense of, if you download the full report, it allows you the opportunity to zoom in on the verticals. And that chart I just presented here, which gives you these various options that apply, exploring options, quantum use case analysis, such, you can actually look at those numbers and parse them out by the 19 verticals that we looked at. And you can start to draw some of your own conclusions about who's taking a leadership position and who's not taking a leadership position in a particular area, which verticals happen to be perhaps more aggressive in use case analysis and prioritization versus proof of concept research programs and such. You could spend an awful lot of time just playing with these particular numbers. I will caution you, though, as we like to say, don't be too flamboyant when it comes to slicing the bologna a bit too thin. As you start to get into some of these verticals, if you remember correctly, in some cases, we only talk to a handful of organizations, say perhaps in defense would be a good example. So don't carry too much weight on some of the organizations that we really didn't have a chance to deep dive into. But for those organizations that we have a reasonable sample size, some of these percentages actually can really add some insights into terms of which particular verticals are moving forward and at what particular stage of quantum computing development they're in right now. When we asked user perspectives about what are some of the problems that they see addressable by quantum computing, the ones that were chosen most often were finance optimization, improving the efficiency of factory processes, and logistics. So these are really, in some sense, ways of tackling optimization problems that face a wide range of companies. It would not be unusual for the optimization in a finance sector to be looking at how to deal with portfolio management and risk assessment in a real-time environment, trying to figure out which tranche of investors instruments presents the highest potential rate of return versus the lowest risk vulnerabilities. At the same time, the idea that organizations that do advanced manufacturing or other types of large-scale production processes are always looking for ways to optimize their workflows. Simple things like, what's the best way to lay out the advanced tooling that happens to sit on a factory floor to minimize the flow of materials, to how often should I order and stock inventory for some of the fundamental materials and other input that I need to manufacture that process. So really, it's here about optimization, but we also saw some interesting attention wanting to be paid to things like quantum chemistry and material problems and staffing and scheduling problems. So these were the ones that when we asked about business problems that the end users thought would be most addressable by quantum. Now, when we said, what is the biggest opportunity that quantum gives your organization, and this is a detailed one, this is more, again, from a C-suite perspective, and the two answers that basically received, I want to say 21% of the responses equally. One was improving research capabilities, and the other was increasing revenue. But if you look at the third most chosen option, driving innovation, and you start to add the idea that innovation and improving research capabilities in some sense go hand in hand, it really shows that while increasing revenue is important, and again, chosen by about 21% of our respondents, the idea of research and innovation is considered a critical value added of quantum computing from end users today. And I think that really speaks to the optimism of what quantum computing capabilities can bring to advanced computing workloads in some of these commercial organizations. And some of the other ones, achieving competitive advantage, enhancing business process efficiencies, realizing cost savings, and reducing time to market, are certainly things that would be on the mind of any reasonable C-suite executive. Now, when we asked them about some of the chief hurdles that are involved with exploring, testing, and investing in quantum computing, one of the things that we found most interesting was the concern about high commitment to existing budget and IT resources. The idea that budgets right now may be stretched somewhat thin and committed to the existing classical infrastructure. And so the ability to include some new quantum computing capability would require some additional funding, or at least some sacrifice in the classical IT budget schedule. So here it's really not as much a condemnation of the cost of quantum computing, because we've seen time and time again that the cost element right now from the end user perspective, purely for quantum computing, doesn't seem to be an overwhelming issue. But here we're talking about more in terms of where can these organizations find either new money or make cuts in existing IT to kind of make way for quantum computing hardware and software. The second most chosen hurdle here, complexity with integrating quantum computing into the existing IT infrastructure, chosen by about half, and lack of in-house expertise and domain knowledge were kind of the big three here. Again, respondents were allowed to pick more than one, so the totals do go above 415. But really, I think what this says here is, from the user perspective, there is still a lot of concern about how quantum can be introduced into their existing compute environment in a way that doesn't require a lot of specialized capability in terms of in-house expertise, in terms of new and different kinds of equipment. So really, from the vendor's perspective, it's more about easing the problems of introducing quantum into an end user facility, as it is to demonstrate things like quantum superiority or first to 1,000 qubit kinds of races. It's more about making sure that end users have the proper support they need to bring quantum into their workload environment without having to commit too much resources, without having to think about integration costs, and without having to think about seriously upgrading their in-house expertise and domain knowledge to take advantage of quantum. I want to give a little summary here about some of the site perspectives that we also gained when we were talking through the point of the survey, just to give you a sense of the organizations we talked to and some of their existing concerns in their classical world and how they ultimately relate back to some of the problems, or some of the solutions that quantum computing can bring to their environment. So when we asked them about what's the frequency of some of the key computing tasks that you currently run, and we gave them some choices here. We picked out machine and deep learning, optimization, modeling and simulation, material science, and data analysis. You can see that functionally, data analysis and optimization lead in terms of jobs that are done at these sites literally either all the time or frequently, with very, very few choices in terms of occasionally or rarely. And what this tells you is that these applications, and we didn't pick them at random, what's interesting here is these applications are currently running on most of either all the time or frequently within most of the sites we surveyed. And it's important because these particular applications or workload problems represent some of the most promising opportunities presented by quantum computing technology today. So there's a wonderful confluence in terms of what kind of jobs are currently running in the end user community that we surveyed versus the kind of opportunities that quantum computing offers at this particular point in time and in the near future in terms of attacking these kinds of important workloads with potentially great improvements in performance. To kind of put some scaling on that, well, this is one of the questions that we always like to ask our HPC users, and it's this idea of unmet demand. And simply put, what this means is going out and asking either a user or a site, if you were given all the compute resources you had, or I guess more accurately, how much more computing could you do if you had the compute capability to do that? And can you express that as a percentage of your current workload? So simply put, if I say I have a 50% unmet demand, that means that if I take my entire existing workload, I could use another 50% more computational capability at a given point in time to be completely satisfied with my compute resources. And what we find, and this turns out in just about every survey we do, is that only about 7.8%, a vanishingly small percentage of end users say, I'm fine, I've got all the compute capability I need. Everybody always wants more. And you can see that the numbers range from about a third said, I'm about 25 to 50%, I have unmet demand. I could use at least 25 to 50% more compute capability just to basically execute the current workload I have. 5%, 100 to 200%, and about a third was between 1 to 25%. We did find some other numbers that talked about 50 to 100%. A few, vanishingly few, said over 200%. But really, what this means is that there is an awful lot of compute capability out there, or I should say, compute requirements out there that are not being met by current compute capabilities in-house. And I think this traces back to that earlier comment about existing IT budget pressure. People simply don't have the kinds of budgets that they need to address the workloads that they have and that they would want to execute. And what this said to me when I saw these numbers is this again offers an opportunity for some of those critical workloads that we just saw in the previous graphic to say, hey, this is interesting. We have some unmet demand for compute capability on our classical infrastructure that is addressable by the potential of quantum computing. And so really what this speaks to is the ultimate promise in terms of how quantum computing can solve some of the most pernicious unmet computational requirements in those 415 different organizations that we surveyed. When we asked about additional current obstacles to solving these computationally dependent business problems, and again, we allowed them to select up to 3, and I thought this was interesting, and there's a message here, I think, for the quantum computing supplier base writ large. The one that was interesting was 43% said too much time needed to implement the solution, and 36%, if you skip down one row, concerned with long computational times to solutions once implemented. And what that unpacks to mean is that the most interesting problem facing end users today in terms of solving their computationally dependent business problems is once they say, hey, we have a solution, we need a solution, we have a problem, and we think we can figure out how to do this in terms of a computational solution. The time that it takes to go from problem definition to implementation to the time you can actually execute the first program to realize that solution simply takes too long. And to me, that speaks volumes about what the quantum computing sector needs to understand in terms of introducing solutions to these commercial sites. So once a problem is identified, a solution can be quickly reached to say, okay, we have a way to address that particular computational workload, and we can address it fairly quickly. Now, the other one is long computational times once solutions are implemented, and that again speaks to the complexity of some of the workloads that are out there and how long it takes to run them. Once you have the problem implemented, now you execute it on a system, and it takes too long to reach a solution. And that could be because somebody wants real time and it takes an hour, or somebody wants a week and it takes 3 months. It all depends on your particular site requirements. But the key here is it's all about time. It's all about getting a solution to a problem up and running as fast as you can, and then reaching that solution as soon as you can. And again, here this is where we see a problem in terms of costly compute resource requirements. And again, this is for their existing classical IT budget. So really what we're looking at again, and I'll reiterate this again, is essentially a, for lack of a better term, a cash-strapped IT infrastructure in a lot of these organizations where they really don't have a lot of money to throw at unmet demand, to throw at new applications. And in some sense, they'll be looking for a real performance boost, a way to get more bang from the buck from quantum computing than they can get just by buying more classical servers, throwing in more nodes, buying chips with more cores. The computational promise of quantum can actually turn out to be, I think, a mitigator when it comes to addressing some IT budget concerns. And then, of course, we see some other concerns here. Lack of vendor solutions. To me, that speaks to the idea of implementing solutions. Vendor solutions, the quantum computing supplier base needs to come in and develop and demonstrate that they have end-use applicability. It's not about demonstrating the most efficient quantum processor or the most qubits. It's really more about demonstrating the fact that you can solve end-user problems effectively. So we're going to jump to the summary here now, and hopefully people have asked a number of questions. So we will have some time to address those. But let me just wrap up with some final thoughts here before we get to those questions. Commercial organizations operating in key markets around the world are actively looking to introduce and use quantum computing in the remote computing environment. The survey says that, and the study of that survey reaches that same analytical conclusion. I think it's really important to note that every vertical surveyed had a significant number of organizations currently involved in some level of quantum computing activity. There's been some discussion, as always, in terms of quantum computing, this specter of quantum winter. Is there too much investment in the sector? Is there too much promise and not enough reality? Well, the thing I point to at this particular point in time is that the commercial interest in the technology. This is not just a push where a certain amount of investment is going to develop quantum computing, and there doesn't seem to be uptake on the pull from the end user side. And so we're at a very sweet spot in time right now where the idea of proving end use performance gains, return on investment, competitive advantage is critical. And to me, the idea that verticals out there are interested in looking and have plans in place say the time is really ripe here for quantum computing to really emerge from primarily a research activity into a development activity that moves it out of the lab and into the commercial space. Already said before, I'll just hit the point one more time. Quantum technology is seen as offering a range of corporate level benefits, including improved research capabilities, increased revenue, innovation, time to market, cost savings, a wide range of potential benefits at the C-suite level. Demonstrating return on investment, not a simple procedure right now to do from quantum computing. There's still some leaps of faith here when it comes to, convincing the accountants and those that write checks that you can guarantee installing some quantum system is going to solve a certain amount of problems from a financial perspective. But certainly the range of benefits seen here indicates that there's a lot of optimism in terms of what quantum computing can do at the corporate level. And finally, I'll just say that data analysis, optimization, and mod sim are already prevalent in many of the compute site surveys, and those site surveys already face significant unmet computational demands, which means they, I think, are really ripe to find some computational solutions that come in perhaps computationally at a price performance that is close to classical counterparts, if not better, and also addresses some of the most critical workloads. So that's basically a quick summary of the report. And if you want to get it, here's the website that you can go to, download it. It's a really nice looking report. I think it runs about 20 pages. It contains a lot more detail, a lot more analysis. And you could get that by going to this site. And if you're not completely convinced, or if you have any questions or comments or feedback, if you just want to chat a little bit more about this is my email address up there at the top, Bob Sorensen, Hyperion Res. And I just want to conclude at this particular point in time by thanking D-Wave for allowing me, as I said earlier, to conduct what turned out to be, in my mind, a very fascinating activity and giving me free rein to really explore exactly what some of the critical elements were in this particular technology.
Great. Well, thank you, Bob. I have put the link for the report in the chat box for those of you that didn't quickly copy it down. Before we get started on the questions, I have one question for you, which is, based on what you already knew and saw in the market from a quantum perspective, what surprised you most about the data that came back from the survey?
I think, to be quite blunt, what surprised me was the amount of ongoing interest and activity within the commercial sector. What you see sometimes in the popular press are, partnerships between some of the major quantum computing suppliers and maybe some developments with some large commercial partners in the commercial sector. And really, I was not expecting the degree of interest and the degree of activity going on across the verticals, because a lot of times, people say, oh, well, right now quantum is it's concentrated primarily in the finance sector because those guys have big money, and B, the potential return on investment through using optimization is there. So right now the financial guys are interested in this, and some people actually say, well, that's the low-hanging fruit. You go after the organizations that have money and have the problems that are most amenable to the existing quantum computing capabilities of the day. This is not seem to be the case here. It's not limited to any particular vertical. I think there's a lot of end users out there who are interested in what's going on in the sector and are trying to figure out exactly how they can bring it into their particular workloads. So it's depth of activity and breadth of verticals interested in activity.
Great, thank you. Now we'll get to the questions from our attendees. And again, if you do have questions, please put them into the Q&A box. First question is, did you distinguish between universal digital quantum computing, adiabatic quantum computing, quantum annealing, digital analog quantum simulation, quantum reservoir computing?
We purposely stayed away from getting down into, for lack of a better term, the nuts and bolts of quantum computing implementations. Exactly how is one implementing the quantum phenomena, what particular architecture they're using, because the key here was to target the end users who are looking at particular solutions. They're interested in how their particular workloads can be performance accelerated. So in the HPC world, it would be like asking an executive, what particular GPU configuration are you interested in using? That's not something that you want the C-suite answering. That's something that once those decisions are made to support a workload, you let the technical experts step in and more or less, for lack of a better term, wade through some of the technical complexities here in implementing those solutions. So we really wanted to keep it at a high enough level of abstraction that we wouldn't get involved in those particular detailed discussions. We have done a whole bunch of other work in looking at things like quantum modalities. Is it going to be superconducting qubits? Is it going to be trapped ions or cold atoms? And that's a discussion left for another day, another audience, and another target analysis. So no, we purposely didn't make that distinction because at the level of expert that we wanted to talk to, the influencers, the decision makers, and the policymakers, they don't need to know that information. And quite frankly, I think they would run fast away from it if they had to.
Right. Okay. How do you see the quantum as a service type usage of quantum computing will develop in the next few years?
Well, we've done a number of studies on quantum computing access models. What are customers interested in terms of how they get access to the quantum hardware? And basically, we are very positive on looking at cloud-based access, at least for the next few years, as being the predominant way that most users are going to get access to their quantum computing hardware and software to meet their workloads. And that's by a significant portion. As I said, at least for the next few years, we'll start to see organizations buying on-prem quantum computing if they have unique privacy concerns or national security concerns. But it's really going to be more about what are their actual workload requirements, as I mentioned, privacy or confidentiality or national security, that are going to be driving those on-prem decisions as opposed to a cost or performance perspective. So we're much more positive right now, at least for the next few years, in terms of delivery through cloud access models than we are with on-prem procurements.
Great. Next question, where would airlines fall in the presented demographics? Transport, aerospace, or possible tech providers to airlines?
I would argue there that it would be transport or aerospace, but we don't enforce rigor with how people respond. I would guess, if I had to, I would think that aerospace perhaps would be more in terms of R&D and development. So I would put Boeing as an aerospace company, and I would put United as a transportation company.
Okay. You may have sort of answered this, but what are the dollar ranges of these users surveyed in-house investment? But the next part of this question was, or spending on QC. So I know that wasn't something we asked, but.
We did not ask about spending on QC right now. Now, this is not a commercial, but in about, I guess I want to say about a month, I'll be making a presentation at another conference, the Q2B conference, where we did actually talk about commitment of IT budget to quantum computing. And I think we sent that survey out to a number of organizations. So we're trying to get that number at this point, but it's still a little bit up in the air. So I haven't really kind of scrutinized the data that's coming in on that. But the numbers, I will say the early estimates are single digit percentages of existing IT budget seem to be the most prominent selection. But please don't hold me to that. And check out the next study that should be available. What's interesting is that particular study was funded in part by the Quantum Economic Development Consortium that's being funded by the National Quantum Initiative here in the US. And so that report will be made publicly and widely available once it comes out. So you can get a little more answers to that particular question when you get access to that survey, but we didn't address it here.
Okay. Next question. Were end users asked about hybrid business models and how they looked at that classical quantum paradigm?
Can you say that again now?
Sure. Were end users asked about hybrid business models and how they looked at that classical quantum paradigm?
No, again, that was a degree of detail, an issue of implementation that we didn't really want to dive into in this particular study. I'm a huge fan of hybrid and in both flavors, if you will, of quantum computing. I've seen issues of hybrid at some level where you've got a compute capability in classical side, and you've got quantum systems, and they cooperate at some high level of abstraction, all the way down to hybrid, where you're literally iterating within, say, for lack of a better term, a nested do loop in a particular program that throws it between the quantum system and the classical system. But we didn't get into specific implementations. But in general, from my discussions with a lot of folks in the sector, there's a lot of optimism in terms of hybrid quantum classical HPC architectures that offer some interesting performance enhancements to classical algorithms in terms of things like HHL algorithms and such.
Okay, next question. Was there any specific interest in power saving compared to classical devices?
We didn't see any specific call out for power concerns, and I'll tell you, we've been doing a lot of work right now on what's going on the classical side in terms of unimagined power consumption issues in the highest end of HPC right now, where you can have a 50 kilowatt rack now without batting an eye, and people, as recently as a few years ago, the idea of anything above 10 kilowatt per rack was considered amazing. But we haven't seen that particular issue. We haven't really addressed that particular issue in terms of the quantum space just yet. And quite frankly, my general feeling is when I look at the quantum systems that are out there right now, their power ratings are vanishingly small on a compute capability compared with what it takes to power a leading edge HPC. And we were talking with some folks a couple of days ago looking at the Aurora exascale system that's going to be installed in Argonne National Lab next year. And that's a 60 megawatt system. So if you can, once you start to look at quantum computing power capabilities as it stands next to, tens or 20s or 30 megawatts in terms of the exascale HPC systems, it hasn't really appeared yet as a deep concern within the user community.
Okay. As we know that quantum computing is still in its development, and there are efforts to resolve challenges which include noise, errors, and scaling them up to commercial needs. Having problems documented and getting them to development and POCs is important. Do you have any feedback on how companies should plan their time frame with quantum needs?
I mean, it's exactly, the idea here is really, it's moving beyond, and again, I agree with everything that was kind of embedded in that question. To me, the next great concern in terms of quantum computing is the scalability issue. It's how much these systems can move beyond the implementation that we see today with the tens or hundreds of qubits to their ability to scale. And that scaling can be through either quantum processors that have more qubits per processor, or the ability to interconnect smaller level processors in an advanced quantum-based network. So to me, scalability is key here. And really what I think any company that's interested in kind of looking at this problem, I think first off, you have to be in the game. You have to have, and I saw, we saw that half the companies really do. You have to be monitoring the technology. And there's a certain amount of fear monger that goes on in this sector that says, oh, it's a hockey stick technology. And the minute it hits, you're going to be left behind if you're not participating. And I'm not such as much of a gloom and doomsayer as that, but the idea of being cognizant of how your existing workload can merge with quantum, I think is a critical element in all this. You just can't wait to say, well, one day we're just going to download an application and we're going to throw it to the cloud through a quantum computing cloud access model and be done. I think there is a certain amount of onus on these potential commercial quantum users to at least explore and kick the can down the road when it comes to understanding their particular workload requirements and how the existing state of quantum commercial application availability merges with those in-house requirements. So it's really, even if you're not committing significant portions of funding right now to in-house research or such, it does pay to monitor the situation to make sure that you're at least planning for the next few years in terms of how you can implicate quantum into your overall classical infrastructure.
Okay, great. We've only got time for about 2 more questions. So I've picked out one that's been asked in a couple different ways. And it's not a naive question from the questioner. What is the main incentive for the companies to participate in your survey?
Okay, I'll tell you right up front. An honorarium is one of the things. It is the fundamental reality of the world today, and this is just kind of peeling back the curtain a little bit to see the man, not the wizard. Nowadays, if you send out surveys and don't make sure that you're talking to the right people with the right backgrounds, and then basically indicate that their time is worth something, then you're not going to get good survey results. So a significant portion of the cost nowadays of doing what we consider to be a survey with credibility and reliability is to supply honorariums. And one of the most interesting aspects of all this, again, this is really inside stuff here, is when you interview someone in Japan or South Korea or Germany, you better have a seamless mechanism to make sure that they each are remunerated in the way that's most trivial for them. So you just can't send out a couple $100 in an envelope. You have to make sure that it's country specific and such. Again, it makes the survey process more complicated, but it helps ensure that the results you get come from the right people and they have been committed to spending a certain amount of time on doing it properly, as opposed to just checking the first radio button that appears on their screen.
Okay, so 2 more questions here. Did you ask about the time frame tolerance of end users to get actual advantages from quantum computing for their applications before they abandon it altogether? Is it a year, 5 years, 10 years?
In this particular study, we did not ask about how much enthusiasm they had in terms of, as a function of time. And this goes back to some points I've been making in a couple of my other talks. And to me, what's key here is it's not really addressing the user perception of, when is this going to hit? It's what we're seeing right now in the quantum computing supplier base, which is, and if you just type in, quantum computing and pick your favorite companies, D-Wave would, be a great place to start. But you can look at IBM, Rigetti, IonQ, whatever. They all have roadmaps right now. And the roadmaps serve a number of really valuable purposes, because if you look at a roadmap now, they'll show you where they've been, and then they'll show you where they are. And that demonstrates progress. It says, look at how much we have moved forward from a technological or a performance capability in the last few years. So that demonstrates progress. If you go to the other side, the T plus side of the equation, that demonstrates commitment. So that says we're in this for as long as it takes. We're here to stay in this particular process. So really what the sector is trying to do from the supplier perspective is demonstrate progress and commitment to future development. And I think in some sense that goes a very long way to convincing users, hey, if I'm not happy with what's available today, or I'm getting a little antsy about waiting around, I at least have a strong sense from a number of different vendors and from the quantum computing supplier community writ large that things are going forward. And I can really start to do the strategic planning that says, well, maybe it's not for us today, but these are some of the goals that I see are going to be achieved, say in the next 6 months, say in the next few years. What it does is it gives a reliable time frame for those users to at least make insightful judgments about where they want to jump in or where they want to stand back.
Okay, and the last question here, which I'm sure is on a lot of people's minds, what is the skill demand for quantum computing?
It's, oh my gosh, we could do a whole separate study on that. Let me put it this way. Does a Python programmer need to know how a CMOS NAND gate works? Thankfully not. And what we're seeing right now in the quantum computing realm is that thought writ large, the stack, if you will, all the way up from application software development down to how I configure a particular superconducting qubit is starting to coalesce, which means that no one needs to know the whole, let me move my hand up here, you can see this, that no one needs to know the whole stack anymore. All you need to know is what's above you in terms of abstraction and what's below you in terms of implementation. So someone can write quantum computing software at the applications level in a Python environment, making calls to a quantum computing supplied library that runs through a compiler that ultimately gets back down to the quantum computing hardware. So the key here is it's not like you need a PhD in quantum physics. We need quantum engineers. We need quantum software engineers. We need programmers. What I've seen, and this is really fascinating to me, is the number of applications programmers and other folks within the quantum computing software development community that come from the HPC sector. And that's because these are people who have made a career out of saying, what's the newest, greatest technology and how can I write code to take advantage of it? And so they have experience in terms of adjusting to the situation, taking advantage of the toolkits that are available, taking advantage of the software development environment to make that happen. So they don't need to go all the way down into the stack. And so to me, that's a very good thing that says what you need across the quantum computing space, except for very certain key development areas like in the hardware scheme and some of the other places, you can have the same general type of IT development stack that you see in the classical world. And so some of the concerns about workforce development, I think, have been mitigated over time simply because that stack has started to coalesce in a way that means you don't need a PhD in quantum physics to run an optimization problem at a large financial institution that ultimately gets executed on a quantum system somewhere upstream.
Okay, well, that's our last question that we're going to have time to address. We will be sending out an email to everybody who registered with links to the paper, which I also put in the chat. Again, this recording of this webinar will be available on YouTube in about a day or so. And stay tuned as we come out with further webinars into 2022. So thank you so much, Bob. It's been a very insightful day. And
Thank you.
I think people will find a lot of information in the report. So
Great. Thank you very much.
Thanks for attending.
Great. Bye-bye.